Now, let's come back to the theory again here. Look at the formula. It says x equal to minus b plus minus square root of b square minus 4ac divided by 2a. Here b and a are outside the square root, but b square minus 4ac, this whole item is inside the square root, right? We also have an information that square root of a positive number, this will be real number, whereas square root of a negative number is imaginary number or a complex number, right? So we need to identify, or we need to put some conditions here also on the basis of this b square minus 4ac, right? Let's do that one by one. Okay, the first condition, let's say case 1, we say that if b square minus 4ac is greater than or equal to 0, we say if b square minus 4ac is greater than 0, what will happen? Then roots are real, right? Real and distinct. Okay, real and distinct. This is very important information. So if b square minus 4ac is greater than 0, then roots are real and distinct. Now here, what we are talking about is the nature of roots, right? We are talking about the nature of roots. What type of roots we will be getting for a given equation, right? Before going ahead, just one more thing. There is a word discriminant coined for b square minus 4ac. This b square minus 4ac, sometimes in the books it is also written as d, capital D. It is actually called discriminant. So the D is the first letter of the word discriminant, right? So this expression b square minus 4ac is called discriminant, not delta. Okay, and why discriminant? Because it describes the nature of roots, right? So the first case, if b square minus 4ac is greater than 0, then the roots are real and distinct, right? Now even in this, there are two distinct situations. Okay, so if I have, let's say, within case 1, let's say first situation, if I have b square minus 4ac is equal to a perfect square. A perfect square, like 1, 4, 9. So what we are saying, b square minus 4ac is already greater than 0. Within this, if b square minus 4ac is a perfect square, then what will happen? Then the roots are anyways already real. So roots are rational, right? Rational and distinct. Okay, look at this carefully again. I'm saying that we already have b square minus 4ac greater than 0. In this, the roots are real and distinct, right? Now, even in this situation, if b square minus 4ac becomes a perfect square, then the roots are rational and distinct, right? This is the only case where factorization is possible. Right? So remember the question that we did with factorization? All those equations, quadratic equations, were following this condition. So this is where we can use factorization method for quadratic equation. Right? In fact, this is the only case. Okay? Factorization method to solve. Alright. Now let's take the second condition. What if b square minus 4ac is greater than 0 but not equal to a perfect square? Then what will happen? Right? Now you see, if it is not a perfect square, see, if it was a perfect square, what would have happened? The root would have gone out, so we would get a rational number. Whereas if b square minus 4ac is not a perfect square, then root will remain there, root will not go out. Now if the root does not go out, what will happen? The roots will be irrational, right? Instead of rational, now it will be, then we can say, then the roots are irrational. Alright. Now, when the roots are irrational, we have already seen in the previous case that in the last 2-3 questions that we have seen, when the roots are irrational, they are conjugate. You remember conjugate? What is the meaning of conjugate? We saw in one of the examples that we had the roots as, for example, I'll just recall, it is 5 plus 2 root 3 and 5 minus 2 root 3, right? So this is the example of conjugate roots. So whenever the roots are irrational, they must be conjugate. Irrational means things like root 3, root 2, root 5 and so on and so forth. Okay, and this is the situation of conjugate pairs. So irrational and conjugate pairs, right? What is the meaning of conjugate? Look at this carefully. If it is one root is a plus b, the other root has to be a minus b. If one root is a minus b, other root has to be a plus b. Remember, sign has to be changed only for the part which is irrational, right? So it is 5. If one root is 5 plus 2 root 3, the other root has to be 5 minus 2 root 3, right? So remember two conditions from here. If b square minus 4ac is a perfect square, then the square root sign will go away and we'll get a rational root, a pair of rational roots, right? If b square minus 4ac is not a perfect square, then the roots are irrational and conjugate pairs, the examples of which we have already seen, right, in the previous cases. In the last 3 questions we have seen that. Okay, right. Now let's take up the next condition or next case